Example 1.9. A small ball of conducting material having charge plus q and mass m is thrown upward at an angle theta to the horizontal surface with an initial speed v0. There exists an uniform electric field E downward along with the gravitational field G. Calculate the range, maximum height, time of flight in the motion of this charged ball. Neglect the effect of air resistance and treat the ball as point mass. Now, I'll explain the question to you. A small mass of conducting material of charge q plus q. So, there is a small mass and it is thrown upward at an angle theta. Now, here you can see the diagram. A mass with charge plus q is thrown upward at an angle theta. Okay, with the initial velocity v0. Now, in the 11th standard you have learned this is a projectile motion. When a ball is thrown like this or projected like this, it will fall to the ground at a particular distance. Okay, so it will experience a downward gravitational force. It will experience a what? Downward gravitational force. Now, according to this problem, this ball is a charged ball. Okay, this ball is a what? Charged ball. So, it has electric field. It has what? Electric field. In addition to the gravitational field, it experiences an electric field. Okay, now what you have to find it out is, you have to find it out the range, maximum height, time of flight in the motion of the charged ball. These three things you have to calculate. That is, you have to calculate the range, maximum height and time of flight. And what you have to do is, you have to neglect the air resistance. So, there is no resistance of air and you have to consider the ball as a point mass. Now, we can find it out. The acceleration of the charged ball due to gravity. Okay. So, acceleration of charged ball due to gravity, that is equal to minus j vector, because it is in the negative y-axis. Then acceleration of the charged ball due to electric field. Okay. Now, acceleration is equal to force by mass. What is your force? Force is equal to charge into electric field by mass. The direction is what? Again in the downward direction. So, your acceleration is equal to minus QE by M into J vector. Okay. Now, what is your total acceleration? Total acceleration is equal to, that is both the acceleration, this plus this, that is due to electric field and due to gravitational field. So, we can write minus J vector plus minus QE by M into J vector. Okay. So, this can be written as minus G into G. I am taking the minus outside, G plus QE by M into J vector. QE by M into what? J vector. This is your total acceleration. Now, here you have to note that the acceleration depends upon the mass of the object. According to Galileo, all the objects should fall at the same rates towards the earth. Is true only in what? Uniform gravitational field. But in addition to uniform gravitational field, if there is an electric field, the acceleration depends upon charge as well as what? Mass. Charge as well as what? Mass. Okay. So, you can write the acceleration as your total acceleration A is equal to, here we are not writing the direction, acceleration as G is equal to QE by M. Now, we can go for finding out the time of flight, range and maximum height. So, first we can go for finding the time of flight. So, for time of flight, the formula is Tf. Okay, Tf is equal to 2 V0 sine theta by g. Here it is, initial speed is what? V0. Okay, so this is the formula for time of flight in projectile motion. Okay, horizontal projectile motion. Here it is 2 V0 sine theta by what? G. Okay, the ball is thrown at an angle theta. So Tf is equal to. So now here I am going to replace this g by this acceleration. So what is your time of flight? Time of flight is equal to 2 V0 sine theta by g plus qe by m. Okay, now we have got the time of flight of the charged ball. Now we can find it out. Horizontal range. R is equal to V square sine 2 theta by V0 square sine 2 theta by G. Here also we can replace G. Okay, so we can replace V0 square sine 2 theta divided by G plus QE by M. This is the range of the charged ball. Now the third thing we can do it here is maximum height, H maximum. H maximum is equal to V square sine square theta by 2G. Now this can be written as, here also we can replace, this can be written as H maximum is equal to V square sine square theta by G plus QE by M. In all the three cases, we have found that G is, the acceleration of the object is inversely proportional to the time of flight. Here it is inversely proportional to the range and it is inversely proportional to the H maximum. Suppose if the acceleration G QE by M is greater than G for charge plus Q, okay, then if this value is greater, this will become what? Smaller. Here also this will become what? Smaller. That is, here the denominator is a greater value. So the TF value will become what? Smaller. So what will decrease? TF, range and H maximum will decrease. Okay. If G plus QE by M is less than G for charge minus Q, okay, then TF, R and H maximum will increase because the denominator value is what? A smaller value. So these values will get what? Increase. Now we can draw this in the diagram. Now I am going to draw for charge plus Q. For the charge plus Q, we have seen that all the values are decreasing. That is the range decreasing, the maximum height decreasing and the time of flight decreasing. So for the charge plus Q, the range is like this. Okay, the diagram is like this. Now for the height is also decreasing. The time of flight is also what? Decreasing. The range is decreasing. Now for charge minus Q, everything is what? Increasing. So how to draw it? So everything is what? Increasing. This is for charge minus Q. So this is for charge minus Q and this is for charge plus Q. This is for the original one. Okay. So this is how the diagram varies.